Hi guys! In our previous lesson, we examined Kirchhoff's voltage law. In this video, I will explain the Kirchhoff's current law, which is as important as it is for us to analyze electrical circuits and one of the most important issues we need to know. Let's try to learn this law through the circuit here. Here, let the mains current IT, the current through the R1 resistor be I1, the current through the R2 resistor I2, and finally the current through the R3 resistor I3. This is where Kirchhoff's current law guides us. According to this law, the sum of the currents coming to a point is equal to the sum of the outgoing currents. There is only one current coming from the source here. We have shown this current as IT as the total current. Hence, IT will be I1 plus I2 plus I3. If we assign the value of IT to the right side of the equation in this formula, it will be negative IT plus I1 plus I2 plus I3 equals 0. So, from this formula, we can say the following. The sum of all currents in a circuit is equal to 0. Kirchhoff's current law is basically like this, friends. Most of the circuit analysis is built on this. The sum of the currents coming into a node is equal to the sum of the outgoing currents, or the sum of all currents in a circuit is equal to 0. Now let's try to understand this formula better through some examples. We can better understand what we are saying through the example here. Here are the incoming and outgoing currents to the node. We know that incoming currents are equal to outgoing currents. The incoming currents to this node are I1 and I2, and the outgoing currents are I3 and I4. Then it will be I1 plus I2 equals I3 plus I4. If we add the current values to one side of the equation, it will be 0 equals minus I1 minus I2 plus I3 plus I4. That is, the sum of all currents is equal to 0. Thus, while the sign of the incoming currents is negative, the sign of the outgoing currents is positive. I want you to pay attention to this, guys. What is the unknown current I4 value in this example? Now, let's try to find it. It is seen that the I1 and I2 currents come to the nodal point, and the I3, I4, and I5 currents go from this point. Then it will be I1 plus I2 equals I3 plus I4 plus I5. If we substitute the values, it will be 5 amps plus 6 amps equals 2 amps plus I4 plus 5 amps. From here, the value of I4 will be 4 amps. Now, let's do a slightly more difficult example, similar to this one. Let this time be an unknown current I3, but both its value and its direction should not be known. How do we find the value and direction of this current? We know that according to Kirchhoff's current law, the sum of the currents flowing into and out of a node is equal to 0. Then we can write the equation I1 plus I2 plus I3 plus I4 plus I5 equals 0. If we write the incoming currents as negative and the outgoing currents as positive, we can easily find the value and direction of the unknown current. It will be minus 5 amps minus 6 amps plus I3 plus 4 amps plus 8 amps equals 0. From here, we find the current I3 as negative 1 amp. So what does the negative mean here? It means that the current I3 is also coming to the node. Its value is 1 amp. If we found the result positive, we could say that this current is going through the node. Now we can easily see that the incoming currents are equal to the sum of the outgoing currents. Now let's try to find the main sequence current, that is, the total current in this example. According to Kirchhoff's current law, we know that IT equals I1 plus I2 plus I3. Then, if we find the current flowing through each resistor, we can find the mains current from their sum. Since the resistors are in parallel here, we know that the voltage across each resistor is equal to the source voltage. Since the source voltage is 9 volts, the voltage across all resistors will also be 9 volts. I1 current will be 1.8 amps from 9 volts divided by 5 ohms operation. The I2 current will be 0.9 amps from 9 volts divided by 10 ohms operation. Finally, I3 current will be 0.45 amps from 9 volts divided by 20 ohms operation. The mains current will be 3.15 amps from IT equals 1.8 amps plus 0.9 amps plus 0.45 amps. We can apply Kirchhoff's current law in all circuits, not just resistors. For example, in a BJT transistor circuit here, the sum of the incoming IB base and IC collector currents to the transistor is equal to the outgoing IE emitter current. Since we use this formula in transistor question solutions, I wanted to show this example, albeit simple. Kirchhoff's current law is basically like this. I hope this lesson was helpful and you liked it. Hope to see you in the next lesson. Goodbye.